Today's lesson is to learn how to find out if a point is a solution to a system of linear equations. So let's make sure we understand what that goal is, what our objective is. First of all, we need to understand what a system of linear equations is. A system is a group of things, a system of different things put together. Linear equations we've been talking about recently. So like one linear equation might be y equals 3x plus 4. And another linear equation might be y equals 8x minus 5. In order to answer the question, is a point a solution to this system? First of all, we need to know what we mean by a point. Now remember, linear equations have more than one ordered pair that makes them true. And that's what we're looking for, ordered pairs. So for instance, I could take the ordered pair 1, 7 and plug it into this top equation, and I could get a true statement. In other words, remember the first number is x, the second number is y. If I plug in 1 for x, and I plug in a 7 for y, does 7 equal 3 times 1 plus 4? Well, it does. So this is a solution to the top equation. But when we're looking for a solution to a system, it also needs to work in the bottom equation. So for instance, if I plug in a 7 in for y, and then a 1 in for x, and then I times by 8 and minus 5, does 7 equal 8 minus 5? It doesn't. So 1, 7 is not a solution to this second equation here, then 1, 7 is not a solution to the system of equations. Now, I think it might be a little easier to understand that if we look at it graphically. So for instance, let's look at this graphically. I have a graph, and I'm going to have two linear equations here. Y equals 2x minus 10, and y equals a negative 2/3 x plus 6. A lot of students have often wondered why I can choose anything I want for x. I can plug in a 1 for x, a 5 for x, and then find the corresponding value for y. So in other words, sometimes the easiest value to find is what we call the y-intercept, which we should know by now. This here is the y-intercept, and we should know that. But again, in this top equation, I could plug in a 0, get 2 times 0 is 0. 0 minus 10 would be y would be negative 10. So this point of 0, negative 10, which is right here on the graph, makes this top equation true. Then we have a slope. Now remember, we've talked about slope. So we should be able to graph this. This slope, again, tells us that I'm going to go up 2 and right 1, which tells me this point here of 1, negative 8, 1, negative 8 should also make this equation true. Let's see if it does. In other words, let's plug a negative 8 in for y, negative 8. So I'm doing this top equation for 1, negative 8. I'm plugging negative 8 in for y equals 2 times my x value of 1 minus 10. And I want to see if it makes it true. Negative 8 equals 2 minus 10. Negative 8 equals negative 8. It makes it true. So this does work. And again, following the slope, I can find more points. I can find this point here, which is 2, negative 6. And then I could find the point 4, negative 4. And I could try those points in this top equation, and they all make it true, which that means we obviously get this line. So I'm going to graph this line here. So every point on this line makes that top equation true. Now, I could keep trying more and more of these points. I mean, I could come out here to 10, 10 and see if that makes the point work. So I could come out here to this equation, put in a 10 for x and a 10 for y. So let's do that. Let's plug a 10 in for x, or sorry, 10 in for y equals 2 times my x value of 10. So I'm trying this point right here, 10, 10, and then minus 10 from it. And lo and behold, 10 does equal 20 minus 10. So it worked. So every point along these works, even the decimals and the fractions and all the points in between. Okay, but all those points only make this one work. they don't necessarily make this next equation work because we're talking about a system of equations. So let's try to look at the points on this one. Now remember, I know what my y-intercept is. My y-intercept is 6, so I'm going to come up here and graph this point right here at 6 on the y-axis. Then I'm going to follow my slope of a negative 2 over 3. So I come down 2 and right 3 and graph another point. Now both those points should make this equation work. Both the point 0, 5, maybe I should even put that you realize that's an x value of 0, y value of 5. This one here is an x value of 3 and a y value of 4. Let's see if they both make this equation true. So in other words, if I plug in a 5 for y, I'm doing this point here, 5 equals negative 2/3 times 0 plus 6. Oh, sorry. I hope all of you caught that. That's not 0, 5, that's 0, 6. There's 5. I just looked at the 5 and said 5, that's 0, 6. I should have went, I even said I went to 6. So that should be a 6. Hope you all caught that. And 6 does equals 0 plus 6. So it worked. But let's see if this 0.34 works. So again, I'm plugging it into this one. I'm going to plug in a 4 value for y. I'm going to do that over here, equals negative 2/3 times my x value. So I'm plugging an x right here, x value of 3. And then I'm going to add 6 to that. And I better get 4. So I get 4 equals negative 2/3 times 3. The 3's cancel. I get negative 2 plus 6, or 4 equals 4. So lo and behold, that point did work. And again, I can graph more and more of those points. I can go down 2 and over 3, down 2 and over 3. And I graph that line. Now, the solution to the system, to both equations, there's only one point that makes both equations true. And hopefully you can point to it and see it. It's where the two lines intersect. It's right there where the two lines intersect. So the one point that makes both equations true looks like I'm over here at a value, x value of 6 and a y value of 2. So let's make sure they both work. And that's really the way you check to see if it works. So I'm going to take that top equation. I'm going to plug in a 2 for y. 2 equals, sorry, you can't see that. Here we go. So now remember, I'm using this point 6, 2. So maybe I'll do it over here. So I'm going to plug in a 2 for y equals 2 times x, I'm plugging in 6, minus 10. Let's see if that's true. 2 equals 2 times 6 is 12 minus 10. Well, 2 equals 12 minus 10 is 2. It worked. This point worked in the top equation. Does it also work in the bottom equation? Let's find out. So for y, I'm going to plug in a 2 again, equals negative 2/3 times my x value of 6. And I'm going to add 6 and see what I get. Does 2 equal, well, 3 goes into 6 twice. 2 times 2 is 4, so I get negative 4 plus 6. 2 equals 2. It worked. So that this point, the point 6, 2 is the solution to this system of equations. Now, you're not going to be asked to graph them all. What you're going to just be asked is to determine if a point is a solution. So for instance, they're going to give you a point. So remember, the first number is x, the second number is y. You got to try it in both equations. You can't just stop with one. So again, if I plug a 1 in for x and 13 in for y into this top equation, so I'm going to do it here, y is the second number. Just remember that. 13 equals, it better equal 8 times my x value of 1 plus 5. And does it? Well, 13 equals 8 times 1 is 8. 8 plus 5 is 13. It worked. It worked. In the top equation, it worked. But it has to work in both. So let's see if it works in both. In other words, I'm going to replace this y with 13 equals, again, my x value is 1 plus 6. Does 13 equal 7? Ooh, it doesn't work. That is not a solution. Not a solution to that system of equations. Let's do one more. Now, the equations do not necessarily have to be written in linear form or y equals mx plus b form, in slope-intercept form. These are still linear form. They're linear equations. But again, I recommend we just replace the x with the x value. Remember, the first value is x, the second value is y. So I'm going to take a 6, times it by a 5, add that to an 11, times by a -2, and see what I get. 6 times 5 is 30. 11 times -2 means I get a -22. And 30 minus 22 is 8, which is what I should have got. It worked in the first equation. Now let's see if it works in the second equation. I'm going to take this 4, times it by my x value of 5, plus 3 times my y value of -2. Well, that's going to be 4 times 5 is 20. 3 times -2 means I get a -6, and 20 minus 6 is 14. And lo and behold, that's what I should have got, was 14. It worked. So this is a solution to the system. Yes, it is. So again, all you're doing is trying the points in both equations, but don't stop at just one. Make sure you check both equations. If you have questions, please let me know.